LED chips are semiconductor devices that emit light and are widely used in various applications, including LED lamps, displays, and automotive lighting. The packaging process for LED chips involves connecting the LED chip to a substrate or other components, directly affecting the performance and lifespan of LED products. Typically, solder paste is used for LED chip packaging because it offers good electrical and thermal conductivity, as well as certain mechanical properties. Currently, common LED packaging technologies include surface mount device packaging and chip onboard packaging, each suitable for different application scenarios. SMD LED packaging entails transferring LED chips from wafers to bead devices for soldering and encapsulation. The bead devices are then surface mounted and soldered onto a carrier board, ultimately forming an RGB display module. COB packaging, on the other hand, directly integrates luminescent RGB chips onto a carrier board. Components are mounted on the backside of the carrier board to create an RGB direct view module. The specific process for COB packaging involves cutting and processing wafers into RGB chips. Next, solder paste is printed on the A side of the carrier board, and the RGB chips are packaged onto the board, followed by the first reflow soldering. When selecting solder paste for soldering, it's essential to follow the principle of using alloys with decreasing melting points from the first to the second reflow soldering. Ideally, the temperature difference between the melting points of solder paste products for the two reflow soldering steps should be at least 30 degrees Celsius. This helps prevent solder issues during the second reflow, such as component detachment or misalignment. For the first reflow soldering, we recommend using high melting point solder pastes like SAC305, tin antimony, or gold tin alloys to ensure product reliability and stability. After packaging is complete, the B side of the carrier board needs to be printed with solder paste, and components such as chips, capacitors, and resistors are surface mounted for the second reflow soldering. Here, we recommend using Fittech Company's low temperature, high reliability solder paste, FL170, 180, and 200. The peak reflow temperatures for these pastes are 170, 180, and 200 degrees Celsius, respectively. Additionally, they incorporate micro-nano-enhanced particles dispersed in the solder, which suppresses bismuth element enrichment. As a result, the reliability reaches 70% to 90% of SAC305, effectively addressing the poor reliability issue associated with traditional low-temperature solder materials. Finally, the completed RGB direct view module should undergo inspection or electrical testing to ensure proper functionality. In summary, the choice of solder paste for secondary reflow packaging of LED chips depends on packaging processes and product performance requirements. Factors such as alloy melting points, particle size, viscosity, tackiness, voids, and reliability should be considered. Relevant data and standards can guide the selection of suitable solder pastes. If you have any questions or requirements, feel free to visit our website or contact our customer service. Thank you for your attention.